Hey everybody, my name's Harry and I'm the CTO at Gadget, and I'm going to explain the new operations dashboard that Gadget just shipped recently. If you go over to your Gadget application and you visit the production environment, this is usually the ops dashboard you're going to want to look at because it's going to have your production data, but you can look at the development one too. That'll report on metrics for how development is behaving. The point of the ops dashboard is to give you deep insight into the way your application is actually performing in production in real time. If you want to understand what's breaking or understand what's slow or make sure that a fix for one of those things actually worked, this is the sort of place you should come to get a kind of zoomed out understanding of how your application is functioning. So let's take a little look at what we've got here. Again, down here in the ops dashboard, the first tab you'll see is the overview. The overview is a description of the key health metrics of your application. So we have all the different HTTP requests that are being made to the app, as well as their status codes, any errors that the application is experiencing, the platform operations that the app might be incurring as it operates, as well as the CPU time. And for this dashboard, as well as all the others, you can change the time range you want to look at to kind of be anything you want. So if I zoom out here on this demo application of mine, I can see I'm doing lots of HTTP 200 status codes. I have a smattering of errors here and there. And, in my case, I know this one's expected and that's fine. This one, I don't know what's up about and I might need to investigate, so on and so forth. A key kind of indicator of any Gadget application's health is what kind of main operations it's doing. So this platform operations chart describes all the kind of units of work the Gadget might be conducting for your application as you sort of tell us to. So things like enqueuing background actions, actually running those background actions are shown here. Webhooks from third-party connections like Shopify or BigCommerce, webhook filtering checks, foreground requests. So this would be like someone actually visiting the UI of your application and loading a front end or a back end element, writing data to the search database, or running kind of syncs or actions. All these are platform operations that Gadget builds, tiny little fees for that you want to be able to count. And this chart, among all the others, often offers a grouping where you can change your mind and see different levels of zoom for grouping these different counts by different dimensions. So in our case, we can group by the type of the operation or the actual operation itself. So in this case, it's like which webhook of the webhooks, is incurring many operations, which route, which models being, search indexed, yada, yada, yada. Or you can see which store, in the case of a Shopify app, are incurring these operations. So platform operations are a big new one that's kind of coming out for Gadget recently. And if you want to learn more about them, they're pretty thoroughly documented on both the operations dashboard guide here, as well as under the account and billing page of the docs. If you just go here and you search platform operations, you'll find a detail about each one of these things. And you can always talk to Gadget support or shoot us an email if you want to understand more about your platform operations. So that's platform operations. So another big important chart on the overview is active CPU time. This chart describes the time spent running your app's code actively on a CPU. So when you get a request and you need to parse the JSON body and then maybe transform that data a little bit and then save it to the database and then reply with a response, each of those little lines of JavaScript code that your app does takes CPU cycles to do, and we count, the number of nanoseconds it takes that line of code to execute and account for it here. Importantly, active CPU time does not count time spent waiting on some request. So if your code, say, makes a write or a read from the database, the code that initiates that read, it takes a bit of time, and the code that processes the response takes a bit of time. But in between, while the database is chewing through that query, even if it's a short amount of time, that CPU isn't actually working on that query, and so that's not billed. Same with, say, a fetch request or a Shopify API request. Active really here means that the CPU is actually doing something rather than just a request was in flight, but maybe, asleep. And this is one of the strengths of Node.js, right? The Node.js runtime is able to do a bunch of stuff and not incur much overhead while it's waiting for outstanding stuff to get back to it. And so Gadget's switching to this billing model of only billing for what's active. For those of you that are building anything LLM powered, this is super important, right? Because when you're waiting on the OpenAI or the Anthropic API to get that long 30-second response back to you, your code doesn't have anything to do. And so you don't get charged for that wait time in this new billing model of active CPU time. Again, you can read more about this in the Gadget docs. This chart down here is the request rate limit usage. And what this describes is how much of your plan's rate limit your app is currently consuming. So each plan that your app is subscribed to has a kind of maximum rate limit. For this app here, it's 500. And then your app, as it processes requests, consumes that rate limit over time. Gadget tries very hard to offer generous rate limits that are high enough for really any app to use. In my case, I'm just using a demo app that has a low one, but there's much, much higher rate limits available on the bigger plans, as well as custom plans that offer really high ones. The reason for these rate limits are just to protect the platform from any one user using too much of the platform, usually by accident. Someone ships a bug, or there's an infinite loop, or Shopify ships a bug and sends a gazillion webhooks at an app. We just want to make sure that the fairness of the platform resources is maintained and nobody can accidentally torpedo someone else by using too much. So the request rate limit usage has a total here, which is all the different operations that your app are performing, costing kind of one rate limit unit. You can see the rate limit doesn't just grow over time like a kind of linear line, and that's because the rate limit refills, right? You're able to use, in this app's case, 500 units of request rate limit every 10 seconds or 50 per second. What that means is Gadget says like every second you can do 50. And if you didn't use 50 the second before, you're still entitled to 50 the next second. And that's done using a leaky bucket rate limit algorithm. So it really is 500 every 10 seconds. You can segment this request rate limit usage by the request type, which describes which element of your application is consuming that rate limit. So let's talk about the different types here. External rate limit usage means requests coming in from the outside world directly to one of your HTTP routes or the front end of your application. In this app's case, it's not getting very much like user traffic or external traffic. People are, in the past 30 minutes, only 2 page loads happened to visit this app. However, it is doing a lot of internal work. And so what these are usually like webhook processing or other background actions that are scheduled to run or have been queued by a different process or whatever. These also consume rate limit. So when you get a Shopify webhook, it spins up, it incurs kind of 1 unit of background processing just to begin to process that background action. And then if it does stuff in the action body, like say reading and writing records or running computed fields or whatever, that costs internal rate limit requests as well. And again, this is just in order to enforce fairness. When you see these things spiking or you're battling rate limit issues where you're worried you're going to clip the kind of limit here, the first thing to look at is like which class of work is causing that rate limit to be exceeded. If it's internal or background, there's kind of one set of solutions, and if it's external, it's usually a different one. Let's talk about the two. So when the main rate limit consumer you might be concerned with is external, that's usually not something you can actually do that much about. It's usually that a lot of users are visiting your application. You're very popular. That's great news. Or external APIs are hammering your routes and sending a lot of traffic your way. You can discourage them from doing that, but you can't actually go edit code on that other store. Maybe you can, but a lot of the time you don't control whatever's sending you traffic. And so the external class is usually something we recommend monitoring and then upgrading your plan if you need to facilitate more traffic. There's always other solutions too, right? Like if you do control or if you can talk to the people on the other end, you can try to ask them to send less traffic or go slower. Or you could even, implement a rate limiter of your own where you discourage traffic. But external is usually something you can't do that much about. Gadget also offers a key platform feature called Surge, which allows you to get out of that sticky situation as well without changing plans if you don't want to. And what Surge does is it allows your application to use more than its rate limit if you've opted in, if you've configured it to, temporarily at an increased cost. So if you say get a flash sale or on Black Friday, Cyber Monday, you're like, I just don't want to touch my plan, my app's working. You can turn on surge, and then if a flash sale does happen, if you do get a huge amount of traffic, your application will temporarily scale up beyond its rate limit, and you can see this sort of number here will dance up above this line, and you'll just get charged for the small amount of time that you're above that line at an increased compute cost. The pricing details of Surge are on the pricing page. And if you're interested in a custom plan from Gadget, because you expect to be surging often, we offer those as well. So we discussed external and how often there's not that much control over it, but you can turn on Surge if you just want to have the confidence your application is going to work. If you don't turn on Surge, or if your rate limit's too low and external kind of reaches the rate limit, those external requests will get a 429 error code. They'll be denied. The rate limit will replenish in the next second, and hopefully the majority of them work the next tick. But that's what happens when the rate limit's exceeded, is that the traffic is denied. For the other two rate limit usage classes, internal and background, there is quite a lot we can do to manage these because we're generally in control of these, right? Background is the number of background actions that are executing all at once, and internal is the amount of work, say an external request is processing where it does sort of internal reads and write operations, or a background action is maybe doing read and write operations as well. There's a couple things to note about internal and background. The first is Gadget goes to great lengths to automatically throttle the amount of background work to a low enough limit that you never exceed your rate limit. We put a lot of work into what we call a back pressure system that carefully dequeues and runs background actions only as fast as your plan supports. And that way you're never paying for surge that you don't need. Your app's running as fast as it can, but no faster among the kind of fairness constraints of the platform. And you're getting as much work as you can out of your app without having to do anything yourself. So this back pressure system that runs, as fast as possible is on by default, and you don't have to do anything. In this application's case, you can see that the background is pretty low, right? We're only peaking at this moment here, 126 background actions were dequeued, over here, 246 were. So we're not actually coming that close to the rate limit. And that means that the back pressure system isn't doing anything. It's just letting them all run. As soon as the background action's in queued, it's going to get run right away because there's lots of rate limit headroom. But if we were right up close to the rate limit max, like zoom out here, see if my demo app, here we go. In these instances where the rate limit was, really under pressure and really high, the system will what's called back pressure, and it'll slow down the rate of background action execution in order to stay under the rate limit. Forgive me for this giant red zone here. I know this doesn't make much sense. This is just because of my demo app. The data under the hood here was being back pressured to a higher kind of invisible limit. But the fact of the matter is the back pressure pushes down this background execution on purpose without you having to do anything on autopilot in order to not consume too much of your rate limit. The internal stuff is also accounted for in that calculation. So you can do whatever you want in your background actions. Gadget will intelligently throttle you to stay within your rate limit. There are, however, moments, like maybe, this moment right here, where you have something really high priority that you want done right away. You don't want Gadget to slow you down. You just need it done because it's important, or say it's in response to a user activity that you've sort of said, oh no, we'll do it right away. And in that case, you can use Surge once again. You can say, I want this background action to run regardless of what my rate limit is. It's okay if it pushes it up above the surge threshold, and I'll pay the kind of increased compute price for that. So maybe that's what happened in this instance on this demo app here. I'm not exactly sure why it's up in the red zone, but what this is a picture of surging where the rate limit consumption was higher than the base threshold, but Gadget still facilitated it and processed these requests at this sort of increased throughput because it was in need and demanded. So the way that you control surge for foreground is you just turn it on or off. And the way that you control surge for background and internal is you mark the background unit of work with a high priority. The default and low priority background actions or Shopify syncs don't cause surge, but the high priority background actions and Shopify syncs do cause surge. Once again, surge is well documented in the Gadget docs. So if you have more questions about the request rate limit, the surge, how to get a higher rate limit, how Gadget back pressures, please research that in the docs, and there's lots more information there. We've discussed a bunch of the overview page, let's talk about actions attempted on the overview page. So this is just a count of the number of actions that have run within your application over time. You can segment it by the type of action, like which verb or was it a global action, which specific action was run. In this case, you can see this app right around 7:02 started processing an awful lot of Shopify product updates. Or you can again look at which Shopify shop installed this app and which is driving the most actions. And then finally at the bottom here, you can see there's another little graph showing the number of scheduled actions that have executed. So these are actions when you create a global action and you add a scheduler trigger, they run here. This shows how often those are executing, and you can segment by all of them or by which action specifically. Okay, and that's the overview dashboard. Let's move on and discuss the worker health dashboard. Worker health dashboard describes the backend Node.js processes that are running your application and how healthy they are. And this is some kind of advanced Node.js mumbo jumbo that we can get into. So I'll explain, but if you have questions, all this is documented in the Gadget docs, and you can find hopefully some answers there as well. So worker health describes each of the little workers that Gadget manages for your serverless application and the key health metrics about each of them. So each line that you see on these charts describes one backend process that's running your app. In this case, this application in this time window that we're looking at here, let's go look at the past 30 minutes. It only has one worker running. If I go back at this time around 7, it had up to four. And then if I highlight each of these, you can kind of see that worker's life. In this case, there was one worker running right up until about 7:01, and then these other two workers started. When you see it rocket up like this is Gadget scaling the application up on your behalf. And then you can see, at least in the case of this green one and this yellow one, these workers were shut down about 7 minutes later because the application's load no longer needed them. The same colors are used for the same workers on the other charts too. So when you're just trying to say like this worker had this event loop utilization, memory usage, or CPU usage, it's all the kind of same identity across these things. So let's talk about the three metrics that describe each worker. Event loop utilization, worker memory usage, and worker CPU usage are the sort of three kind of like holy metrics that describe how healthy each worker is. Let's talk about memory and CPU first. So memory usage describes the memory usage of the process all in. And what I mean by that is there's the Node.js process that Gadget serverlessly spins up and down for you. And then any packages that your app includes can consume memory. Any sub-process that you run can consume memory. So if you're say you're running, Puppeteer or something like that, that would contribute memory usage to your application here as well. You can see that usually memory usage is fine, but if workers get busy, they tend to use a lot more memory. And what that is just that's the way Node works. It's good at taking in lots of stuff. It has to allocate some memory for all the requests that are being processed, but it's good at garbage collection where it won't use, more memory than you've told it to use, unless it's forced to from, say, a memory leak or something like that. So in this case, I don't see anything too alarming on this chart. I see a worker that was bored and then got slammed with a bunch more work to do. I see Gadget correctly serverlessly scaling up these three other workers. And then in the case of the yellow one and the green one, they were shut down later where memory usage goes to 0. And that's like a normal event. And it's an anomaly in the sense that something happened here all of a sudden. If we go look at the overview, you can see we did a lot more requests at this time, did a lot more actions. It makes sense that we need more workers. But what I don't see is evidence of them being unhealthy. They're just working hard. And that's kind of the nice promise of Gadget is we scale this up. We add more capacity as needed. You get to keep on sleeping or vibe coding or doing whatever it is you do. And our system manages this for you. Same with CPU usage. I see this worker here, hanging out until about 7:01. Then it gets really busy because it's the only one. And then as Gadget adds more scale, we see the other two workers step in, the load sort of equalizes, and then those other workers are shut down. So that's all well and good. The CPU usage describes the same sort of CPU usage you might see in Activity Monitor on Mac OS or Task Manager on Windows. It's how many CPU cycles each worker is demanding of the underlying server under the hood. And finally, event loop utilization. This is a really key metric that's a Node.js specific metric that describes how busy the worker actually is. So CPU usage is measured in cores, And you may have seen that in like, the percentage sign in Task Manager or Activity Monitor. But event loop utilization is actually a really useful Node.js specific metric that describes on a scale of 0% to 100%, how busy is this worker and how much capacity does it have left. And so that kind of initial worker that was up at the beginning of this process, it gets slammed. It hits 100% CPU usage because all of that load arrived all at once. And that's not ideal, right? Like, we don't want this worker to be saturated, but Gadget was very quickly able to deliver a second worker and a third worker that also are busy right as they boot, but then the event loop utilization comes down and these workers are now kind of more evenly balanced over time. So usually when reviewing production issues where, say, things are slow or you're getting timeouts or you're suspicious that perhaps the workers are overloaded, the right metric to look at is this event loop utilization, because this describes at this moment here, Node.js was working as hard as it possibly could. It couldn't go any faster. It didn't have any more capacity to do any more work. And if you see a worker that's pegged at that, it's stuck at 100%, that can cause all sorts of problems. It means that the work that the worker is trying to do is delayed because there's not enough capacity to actually do it, and it's going to go slow. There's going to be excessive timeouts. There's going to be all sorts of problems. It's okay if it happens temporarily, but it's not at all okay if it's stuck at the top. So before we talk more about debugging and diagnosing issues on this page, I just want to take a brief aside to talk about what the heck Gadget does under the hood to run your application. Everything I'm about to describe is in the runtime environment guide in the docs. This describes this all in detail, so if you want more information, you can find it here. But let's talk about it real quick as well. So Gadget is a serverless platform in the sense that you don't have to buy servers. You don't have to, choose the scale that your application runs at. Gadget auto scales your system by adding and removing capacity as it goes. Adding and removing capacity is done by adding and removing more of these little worker nodes. What we don't do is something like AWS Lambda, where we start a fresh worker for every request. And the reason that we don't do that is that it's horribly inefficient. It's really, really wasteful to spin up a whole VM or a whole system just to process one request and throw it away. I know Lambda has added more stuff to do that since, but some people still think of serverless as one computer runs one request at one time, never more than one request simultaneously. And that is like a early 2000s, great way to waste a lot of money, both yours and mine, to be honest. So the way that Gadget works is we spin up a Node.js worker that processes many requests simultaneously. This is a Node.js best practice. This is how all the big kids deploy Node, and really what we advocate for. We start one worker. It can process usually an average amount is 60 to 100 simultaneous requests. And that Node.js worker works on all of them at the same time. More can arrive before the first one's finished. That's the strength of Node. And, depending on how many are arriving, there's a certain amount of event loop utilization that creates. If one of those workers is getting too many requests, or it's getting, a small number of very expensive requests, that'll drive up its CPU usage and its event loop utilization, and Gadget will spin up more workers. And then that kind of carries through until the capacity evens out as we wanted it to. And then Gadget will remove workers gracefully when there's not enough for them to do, when they get too bored. So that's what happens over here. The key thing to know with this is that while much more efficient, because you're only paying for this one worker to do many requests simultaneously, it can cause issues where an error in one request can impact other requests that are being processed simultaneously on the same worker. So if this little nj8db worker happened to crash right here, or some request through an error that tore down the process, like did a process.exit1, all the requests that were in flight on that worker at that time would also crash. And that can cause really confusing logs, because if you're looking at the log of one of the victim requests, it looks like the request started fine, and then all of a sudden out of the blue, it just stopped or it errored, and it's really unclear why. If you happen to look at the request that caused the crash, you might find a more informative error. But often what you need to do is you need to come here, look at this worker health dashboard and be like, aha, I see this worker. It had excessive memory usage and then it crashed because it was out of memory. Or I see this worker ran up to 100% event loop utilization and was stuck there for a long time. That's why all the other requests failed, is it was in an unhealthy state. So just a quick review. Gadget runs each app using serverless workers that process several requests simultaneously. Because of that, errors in either worker health or code and bugs can cause a failure in one request to impact other requests. And usually the best way to debug that is to try to come to this worker health dashboard and look for signs of unhealthy workers. So the last thing I'd like to touch on this dashboard is, what are those signs of unhealthy workers? I don't have thorough examples of each, but I'll describe them for you now. So the first one would be sustained 100% event loop utilization. This is what a healthy worker looks like, where it peaks and its event loop is not stuck at 100%. But if we saw a line come up and stay at 100% for a prolonged period, that worker is super overwhelmed and is going to cause timeouts and other errors. The reason it causes timeouts is because its backlog of work to do is just growing. It can't chew through it fast enough, so everything takes longer, everything gets slow, we see timeout errors. 100% event utilization is avoidable. It's usually a bug in the code or using a library that does a really expensive CPU blocking operation. There's a lot of kind of reasons it can happen, and it's bespoke. But if you search for don't block the event loop, Node.js itself has a really detailed guide on exactly how to avoid these 100% event loop utilizations, or also known as event loop blocks. So this line being maxed out indicates that problem. Another really common problem is out-of-memory errors. So what that would look like is a worker having a fair amount of memory and then slowly rising and then clipping the top and then rocketing to the bottom and then kind of slowly rising again. I don't know if everyone else calls it this, but I call it shark fins, because what it looks like is a kind of rising wave and then a very steep descent, and then another rising wave and a steep descent. And what that is the worker is slowly using more and more memory. As it leaks memory or as something goes wrong within the worker, it eventually consumes more memory than it's allowed to. And then Node.js crashes because it can't allocate more memory for whatever it needs to do next. So those out-of-memory logs will be visible in your Gadget log viewer. You should be able to go find them here. However, you may not find them associated with exactly the request that crashed. That's because when an happens, an out of memory or an when those errors happen, it's kind of a general system error that isn't associated with one request, and Node.js doesn't even know which request actually caused it. It's just the conditions were such that there was no more memory, and whichever request went to allocate it wasn't able to get it next. So usually what you need to do is just search for the string in your logs. Let me see, Node.js example. This is what it looks like in the logs. It'll say this is all text coming out of Node.js. If you just search for this JS stack trace phrase or last few GCs phrase, that's a clear sign in your logs that you're getting errors, as this is what Node.js logs when there's an out-of-memory error. And then finally, CPU usage. This is a kind of less informative version of event loop utilization, but we decided to include it on the dashboard still in case you're doing something deeper with your Node.js application, like PDF processing or web crawling or orchestrating a Chromium under the hood with like a Playwright or a Puppeteer or something like that. Basically, if you're using sub-processes, your Node.js process can be bored, but the VM that your application runs on can be saturated by those sub-processes. So this kind of follows the same pattern or the same failure modes as the one above, where if you see CPU usage maxed out at this 1.5 core limit, something's probably going wrong and we need to see how to re-architect the application to not use so much CPU. I think that's the worker health dashboard. Okay, let's move on to the database tab of the operations dashboard. Let me zoom out here a little bit. So this tab of the operations dashboard describes the health and consumption of your serverless database powered by Gadget. The first big chart across the top here is the number of database queries your application is running over time. This is everything that you might do with one of your Gadget data models, be that reading data, writing data, either via the public API or the internal API, running computed views, etc. You can segment this by which model is being worked on, which kind of query it is, be it read, write, or live, as well as just the total. And then after that, we have the kind of usage metrics of the database that are what your application is built on. So in the new pricing model for Gadget shipping February 2026, Apps are billed based on the number of bytes they read and write from the database. And what these metrics are like low-level Postgres instrumentation metrics that describe exactly how much data was scanned or updated when you read or write data. In the case of reads, it's how much data was scanned by all the Postgres subsystems to facilitate your query. And when you write data, it's how much data was actually added into Postgres and changed in the table. These low-level metrics are comprehensive and they track every single thing that the database does under the hood. So in the case of bytes read, when the Postgres subsystems do all their fancy stuff to read indexes, to read table data, to read data out of Toast, which is like a Postgres subsystem for large values, all of that kind of builds up to add this value. And so these can often be really high. In this case, this application, Postgres scanned 885 gigabytes of data in the past 24 hours. The good news is the price per scanned gigabyte is like super duper duper low. These numbers are often high, but that's just normal. That's how much data Postgres has to scan to do work for you. And so don't be alarmed when you see many hundreds of gigabytes or terabytes here. That's very normal and it's not that expensive. We can also see this same value on a query count basis. So as opposed to the gigabytes that Postgres read off of the disks and from the caches, we can see how many times did it do a query. And that usually follows the same sort of pattern. But the difference might be you can do a small number of read queries that are cheap and they don't read very much data. Or you can do a small number of read queries that do read a lot of data. And so in this case, this app has a difference where, around 8 a.m. here, we did 622,000 read queries. But if we look at the bytes read, there's this one sort of standout here where we're reading a lot more data from this model. And so this is like a good indicator that one of the read queries in this application could be optimized to scan less data, or if it's super expensive, it could be issued less often to save a bit of money. That's bytes read. The companion over here is the bytes written. And so this is anytime your application updates a model or creates a new record, changes a record, deletes a record, Postgres has to go change the data on disk, both the indexes and the table data itself, to record that happened. The numbers are often much, much smaller, like usually between 100 to 1,000 times smaller than bytes read. And that's just the way that Postgres works. Write less data than read. Again, same, we're able to break it down by which models being written to. And we can look at either this on a gigabyte by gigabyte basis or just a query count basis. And then below, we have this table here, which is a list of all the fields that are indexed on this app. And so what that means is they can be sorted and filtered on. This is a rule in Gadget, which is if you want to be able to sort or filter on a particular field of a model, there has to be an index for it so that the query for that is performant. If you don't need to sort and filter, you can turn the index off, which saves you money, both on the read side and on the write side. But if you do need to sort and filter, you need an index. So that's configured over like in your application on the schema page here, or here. I guess I can't change production right away, can I? But over on the schema page here, I can adjust this index for filter and sort value, and that determines whether or not I have an index in production. So back over here on the ops dashboard in production, where am I here? This is a comprehensive list of all the fields that I do have indexed and whether or not they're in use right now. So in my case, my little demo app has fake data, and I apologize, these usage counts are all wrong. Please ignore the man behind the curtain. But in your application, these usage counts describe how many times your app has sorted or filtered by this field of this model, which kind of indicates to you if it's safe to turn that off. And so if you want to save some money, if you suspect you have a bunch of indexes that aren't being used, which many existing Gadget apps likely have quite a few because by default, everything has an index. If you want to remove some of those to save yourself some money, you can come in here, you can review which ones have a usage count of 0, and then you can go disable those on your development environment, and then you'll no longer be charged for that index. You can also do that whole process automatically by clicking this here Optimize Indexes button, which will just automatically disable any sort or filter index that has a usage count of 0. Gadget uses data from the past 90 days to power this, which is usually enough to know if you've actually made use of something or not. But if you don't trust that assessment or you'd like to make some changes, you can always do that before you deploy to production. You can click the Optimize button, review the changes that were made, adjust them, and then deploy. But yeah, fields index for sort and filter. The whole point of this is just to help you understand what you can disable and what you may need to keep. And then below that, we have the database rate limit usage charts and the database storage chart. For the database rate limit usage chart, we have a time series of how much consumption your app drove of the Gadget database. The units here are kind of weird. It's measured in time. So let me zoom in on a spike here. What this says is for this time range, for 12:01:30 UTC in that 30-second period, this app did 55.9 seconds of query time. And what that means is queries were running for 56 seconds total within this 30-second period. And it's kind of weird, right? That 56 number is greater than 30, and that's just because more than one query was running at once, right? There's many workers, much parallelism of the application that allows the database to be driven harder than one query running at all times, which would be 30 seconds per second of query time. In this case, we're at 56 seconds of query time. Most of the time, this app is not working the database very hard. It's only doing 90 milliseconds worth of queries, or here's 4 seconds worth of queries in this 30-second period. Yeah. So a second of query time is just Gadget measures from the start of the query to the end of the query, how long did the query take, and then we sum that in each little time bucket here. The reason why there's a rate limit here at all is, again, just to provide fairness to the platform. We don't want any app to be able to spam queries and suck up resources that should be available to other applications. That's not fair. Everyone wants their app to stay up and online. And the database rate limits are quite generous. It's hard to clip the ceiling unless you're sort of really, really trying and using as inefficient queries as you possibly can. So yeah, if you're finding that your database rate limit is reaching the ceiling though, either you're perhaps a really big app, or you're making heavy use of computed fields or computed views, or something that does like a lot of aggregation, you can find yourself in a situation where you're reaching the top, and Gadget offers advanced, bigger databases to help solve with this. Usually what we can do is stick you on your own database where you sort of have full reign. That way you're not threatening anybody else. You can use that entire database for yourself, and we make that available on a custom plan where you sort of get that advanced feature. So if you're running into database rate limit issues, you can talk to us about a custom plan, or you can try to optimize some of your queries to make them less intense. Coming back to this bytes read or bytes written, if you're able to identify a query that's scanning too much data, or maybe you have too many indexes that need updating on writes, you can optimize your database usage to try to bring down this database rate limit and make those queries go faster. Over on the side here, we also have database storage. This just describes how much data is stored total in your database over time. If we zoom out to a 7-day, let's call it 24 hours here. Sorry about that. You can see my app is slowly adding more data, not very much over time, right? It starts at 44.7. After 24 hours here, I'm at 44.9. So I added 200 megabytes. I'm not too stressed about that. But again, if I want to optimize this, I can remove some indexes, delete some data from my database, so on and so forth. And then at the bottom here, we have file storage. This describes data stored in file type fields. So back in my model, if I have an example called like a PDF model with a file, that's the file type field. This is how you use Gadget to store data in cloud storage buckets like Amazon S3 or Google Cloud Storage. The file field type kind of manages that for you if you're unfamiliar. And file storage on the operations dashboard just measures how much total file storage you're using over time. So in this app, we're pretty heavy on the file storage. We use 707 gigabytes of file storage. Yeah. And just to note, this is the data that's in Postgres database storage, and this is the data that's in Google Cloud Storage file storage. This one is a little bit more expensive than this one. This one's really cheap. And that's the database tab. Let's move on to the search tab. The search tab describes your application's full text search infrastructure and how it's performing. Gadget runs Elasticsearch cluster on your behalf and automatically indexes your changed data into this Elasticsearch cluster to make it available for search. That's what powers the search or if you have it enabled, the search in the data viewer here, or the search API for your application. Oops, I'm gonna switch back to production ops dashboard here. So in my production search dashboard here, I can see how much data is being written and what's being searched. Here I have the search requests. In my application's case, I think I've only done 1 or 2 product searches, like super rarely recently. So I haven't really done very many at all. You can see my read queries were 1 here and 1 here. And then I can also see the search indexing work. So because of the nature of search, where it's expensive server-side operation to run, we use 2 different databases. We use Postgres to store the data and Elasticsearch to facilitate searching the data. And that means that your data, every time it changes, has to be indexed out of Postgres into Elasticsearch. And that's what this chart over here describes. It says how much data did we write to Elasticsearch and how many queries did Gadget make on your behalf to write that data to Elasticsearch. In our case, in the past 24 hours, this app has had 206 megabytes of data search indexed and 45,000 search queries. If you were to say stop changing Postgres data or stop writing to Postgres data as often, these numbers would go down because there's not as much changing on the Postgres side. So Gadget needs to do less work to lift it off over into Elasticsearch. We also describe in this table here which models are indexed for search. What this shows you is how often are you actually using that search functionality and taking advantage of the Elasticsearch instance to search your models. In my case, my demo app is a little messed up here. This should probably read 2, but I haven't actually searched these other 2 models at all, right? The GDPR request, sync shop, I haven't used them to search. And so these models, I could probably disable the search index on to save myself some money. I don't need to be paying for all this data changing to be indexed in the search database because I don't offer that in my product and I don't care. So I can click this Optimize Indexes button, which will automatically disable the search indexes for these models that have never been searched. Or I could go off into my development environment, go over to the model itself. Where are we here? And come down to all these fields. Where are they here? Turn off the index for search option on all of these. Once the index for search option is disabled on all these fields, the entire search index for the model will be removed, and you'll no longer pay for any indexing operations to update that model. If you do want to keep the search index for a given model, you can do that too. You can click the Optimize Indexes button. Oops. Let the AI assistant automatically disable all the models that don't need to be searched and then re-enable the ones that you want to keep, or you can just do the stuff yourself manually. It's up to you. And then finally at the bottom here, we have the search storage chart. What this describes is the amount of data total stored in the search database on your behalf. Again, this is influenced by which models you've enabled searching on. All existing Gadget apps by default have search on for all these models, and you're not billed for that until the new pricing in February 2026 rolls out. And so if you want to make sure that you're not charged for search indexes that you're not using, make sure to click this button and deploy before that new pricing takes effect. And that is the search page. Okay, let's discuss the background actions page in the operations dashboard. So this page describes everything there is to know about what background actions are being processed by your app, what background actions are queued and will be processed soon, as well as what's failing and is retrying. So up at the top here, we have this view of background action attempts. And what this shows is how many background actions are running an attempt over time and how many are succeeding and how many are failing. In this app's case, we're in a really great spot. We're doing 99.97 success rate, which is great. The occasional job, 93 over the past 24 hours is failing, and that's okay. I'm comfortable with that, as the app owner. But I can also break it down further if I want to know which queues are processing the most background action attempts or which actions are running the most often. So in my case, it's mostly product updates, a bit of this product log stuff, some Shopify sync events, so on and so forth. I can also zoom in here on a particular kind of space and see I had a big, spike in successes here. What was it? It was mostly product updates still. Below the attempts view here, I can see the queued background actions chart. And what this shows is the count of the actions waiting to run. It's not the actions that are running, it's the ones in the queue that haven't been run yet. So in my case here, I have this events sync queue that's growing over time. Then I also have this queue, the product variant audit log queue, that got really big right around 6:45, stayed kind of big, and then got worked off by 8:45 here. So at the total view, I can see this is all the jobs I have queued, and in the queue view, I can see which queue. And this kind of looks weird, right? The whole point of the background action system is to run that work in the background, but as soon as possible. The reason why you might see growing queues like this is because of the concurrency limits that you might apply to your queues. So if you're saying, do only 2 jobs to write to this particular Shopify shop at a time, you might see a lot of writes kind of accrue, and because only 2 can be processed in that queue at once. And this chart is exactly how you'll identify that. If I zoom out here to 24 hours, we can see that this, how about last 12? See that this queue, this event sync queue for this one shop has been growing like crazy, but all my other queues are really, really small. And that kind of gives me confidence that things are fine. I don't really need to worry about anything other than that one queue. This is probably something I should look into on my demo shop, why this queue is so big. And next to the queue list, just a final thing to stress here. What this is and what these numbers down here represent is the maximum queue size at that time, not the number of jobs queued at that time. And this is a subtle difference. What this is saying is the queue had a length of 4.67 or 4,680 jobs. And you can see over time, that's not really changing. And that's because either the rate, either no jobs are being processed, or the rate that the queue is being filled up is the same as the rate that the queue is being consumed. What this is not saying is every time along here, a new 4,680 jobs were queued. This isn't the rate of jobs being added, it's the size of the queue. Next, let's talk about the failed background action attempts. This is just a list of which background actions are failing some of their attempts and why. So if I zoom out to an hour here, that's not very helpful. I didn't have any failures. How about 4 hours? So in the past 4 hours, I've had 18 failed attempts. Note that this isn't the job overall. It doesn't mean that the entire background action failed. It just means one of the attempts in the action's execution failed. So I have a total of 18 failed attempts. Is mostly on this queue, one was in this queue, but 17 had no queue at all. Let's look by action. 16 product updates, 1 shop sync events, 1 shop update failed. And then the other thing we can group by is, was it the first attempt that failed? Was it a retry in the middle that failed, or a final failure where it's it ran out of attempts? In my case, it was all 17 first attempt failures and then 1 second retry. And then it doesn't show it here, but there are no final failures, which means all these jobs eventually actually succeeded in the past 4 hours. None of them hit their retry limit and permanently failed. So that's good news for me. And then down here, if I look at the running background actions, this describes how many actions are actually executing at a given point in time. It's kind of an instantaneous count of actions being processed. So in total, it looks like the max that was ever being processed was 29 or 30, 27 here, and I can group by queue. It looks like, this product logs update was some of it, but no queue seems like the most common background action execution. And this is just useful for understanding what's consuming your capacity, how fast are things being worked through on a sort of moment-to-moment real-time basis. And then finally over here, I have canceled background actions. This just describes if I go in and cancel an action, or I use the API to cancel an action, how many and when were the actions canceled. I haven't canceled any actions recently, so nothing shows up on my chart here. But if you do a bulk cancel, or you're trying to make sure something goes wrong and you queue way too many jobs, you want to cancel them, you can run the cancel, and as it executes, you'll see the canceled count grow over here. So this is the background actions dashboard. Let's talk about a couple ways to identify problems with your application on the background actions dashboard. So the first problem is a growing queue. What that generally means is I'm seeing more actions arriving than are being processed, and the queue length, the number of actions that are sitting waiting to execute but not executed yet, is getting bigger over time instead of smaller. Generally speaking, we want to see queues have a little bit to do, maybe they grow a little bit, but they should always be coming back down to 0, kind of hovering around 0. There's blips, but it should be rare that a queue is fully saturated for a long period of time. And in this case, I have that bug right now. I have this queue that has been fully saturated for a long period of time. So this is a bug. I need to go look into, did I set the concurrency queue too low here? Do I have an infinite loop that's pushing too many jobs to this queue? I'm not sure, but this is definitely something to look into. I should be seeing this queue come down, like this one, right? If I come look over here, this product media audit logs queue, we bumped up to 402, but then, over the course of this 15-minute period, that queue was worked off, and now there's no jobs left to do. So that's sort of what a normal spike looks like, and this, merits investigation. Another thing to look out for would be a lot of failures, right? In this case, this is a pretty low smattering of failures, maybe from Shopify API rate limit issues or other kind of transient stuff. This doesn't freak me out at all, but if I saw this number was in the hundreds or the thousands or something like that, I'd be freaking out, right? The jobs aren't supposed to fail much at all. Every time they do, it means there's a retry, which costs me another platform operation and a little bit more CPU time. So retries are definitely undesirable, and this is a good one to monitor to understand, is your application retrying too frequently or incurring more compute than it needs to because it's failing more than it needs to? Yeah. I guess, and then one final thing to be aware of on this dashboard would be the absence of attempts. Sometimes you want your app to be running lots of attempts, but it isn't, and it's confusing why. So if I were seeing this be 0, instead of, up here healthily around the, 500 mark, that'd be confusing. And this is a good dashboard to understand that that's happening, but the reason for that is almost always concurrency limits. When you go to run a background action, let's see here, background actions. Let's go over to the table of contents here. When you go to run a background action and you enqueue it with a specific queue, the default concurrency for that queue is 1. Only one job from this dedicated queue is allowed to execute at once. And that can often mean if you have a lot to do, like too much to do, that queue can get bigger because 6 things are adding jobs, but only one's allowed to execute at once. So when you see the absence of attempts that you're expecting, usually the fix is to bump up the max concurrency if your kind of situation allows that, to allow those attempts to happen more frequently. And I think that's the background actions dashboard. Okay, let's discuss the traffic page in the ops dashboard. What this is an overview of the HTTP traffic that your application is facilitating. For apps that do a lot of HTTP traffic, it's really useful. So if I zoom out to, say, 12 hours here, in this app's case, in my little demo, I don't really do that much route traffic. This is mostly a Shopify app that processes Shopify webhooks. I have the occasional merchant load, the embedded app within Shopify to view my app's experience, but it's not really that frequent. And so I can see over here, I'm doing, a handful of requests every so often. If I break it down by route, oh look, 14 of my requests were for the favicon, and I got 1 for the history route. I can also see that none of my routes errored, and I can see the amount of bandwidth that my application pushed out through the internet to serve these routes. In this system's case, it was 80 kilobytes at this one request, and after here, there's no bandwidth, and that can happen because of cache hits. So don't be alarmed when you see that. For applications that use Gadget as an image host or a file host or something like that, you will see this outbound bandwidth jump up pretty high, because every time you serve a file, it can incur those outbound bandwidth charges. And the cost of this isn't very high, but it can add up if you really use this as a CDN. So this is one to pay attention to see if your costs get out of hand. A lot of the times the fix is, if you're a Shopify app builder, to use Shopify CDN instead of Gadget CDN, because Shopify offers their CDN for free. It's like a nice, easy hack. Or if you're dissatisfied with Gadget CDN prices, there's lots of other CDNs you can use as well. And then below the route requests, route errors, outbound bandwidth, we also have average page load time. This is just a really light web performance monitoring tool that helps you understand how your end user experience is working for the experience of your application. So when a user downloads, the web page and runs your application, there's the route request that kind of serves the HTML to them. But then there's also the browser downloading all the JavaScript assets, the CSS, executing and rendering the page, yada, 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 that leads to the core web vitals metrics like LCP and the others. Gadget has a script that is baked in by default to most template applications that measures this and reports back to power this chart. So in my case, this one route load that happened at this one time, get history, the page load time was a max of 192 milliseconds and an average of 2.23, which is really, really fast. Yeah. I think that must have been a computer loading that rather than a human, because that's too fast. But anyways, if you have the web performance script still installed, you'll see much more detailed data about all the routes that your application is loading here. And if you do see 0 data here, it's probably because you've removed that web performance script, which is okay. That's up to you if you want to do that for your own web performance. And that's the traffic dashboard. Let's discuss the Shopify dashboard in the ops dashboard. So this is a special tab that only applies to those of you who might be building Shopify applications with Gadget. If you're not building a Shopify application, this tab won't show up and you can ignore all this. For those of you that are, this is a really helpful understanding of which of your Shopify shops are demanding the most of your application and how your interactions with the Shopify API are going. So right at the top here, we have a list of outbound Shopify API calls. What this is all of the stuff that Gadget does to Shopify on your behalf, as well as what your code does to Shopify is measured here. So we can see that by status code, most of what we're doing to Shopify is working great. We did, 279,000 API calls to Shopify in the past 12 hours, and that was, 200. A few of these didn't go so good. We got 403s, 502s, 402s. In this app's case, we did really good. We got almost 0 429s, which is genuinely very impressive. Great job on building the demo app. We can also group this by which shop I'm doing requests on my behalf. So it looks like this Tiger Medical one is absolutely huge, what I'm doing kind of mostly. But we know they all worked, so it doesn't even necessarily matter. I will note you need to use Gadget's Shopify API client for this chart to gather data. It'll always gather data about Gadget's sync operations and that kind of thing. But if you're using your own Shopify API client or say like raw fetch calls or something like that, that data won't be gathered here. As I said before, there are no rate limit errors, but this is a major pain point for a lot of Shopify app devs where the rate limit is too low and unhelpful from a lot of Shopify applications. So if you're seeing a lot of 429s, you'll see this chart populated with which store is getting them, which action is causing them, and that kind of thing to help you kind of debug and diagnose excessive 429s. I'll make a quick plug for a recently launched Shopify adaptive rate limiter feature of Gadget. You can learn more about this in this background actions guide, but the long and short of it is that you can ask Gadget to only run background actions as fast as the Shopify rate limit allows in order to really, really reduce the rate of 429 errors. So look on our blog and in the docs for details on that if you're finding you have too many 429s. Below those two charts, we have little details about webhooks. So you can see how many webhooks you're receiving by topic, and again, by which shop is receiving them. This is really useful for understanding why you might be paying for a lot of webhook processing. A lot of Shopify apps, it's the bane of their existence is trying to process fewer webhooks in order to pay less, but still, do what they need to do to make their application work. So this is really, really useful for understanding, okay, it's this topic that's driving, 98% of the webhooks I'm getting. And in this case, this one shop, they update their products an awful lot. And so we're seeing a lot of product update webhooks from them. When you see these numbers being too high, or you're on a kind of cost optimization adventure to try to improve this, the first thing to reach for is webhook filtering. This is like a feature of Shopify that allows you to disable webhooks to not fire when you don't need to know about a specific change. You can say which fields you want to know. So that's our kind of chart to help you understand what you should be filtering and what's driving your costs. Over on the side here, you can also see webhook-triggered actions. And what this is when the webhook arrives and it goes and runs stuff, what stuff did it run? So when I search by total, you can see lots and lots of webhooks are being processed and running lots of actions. When I group by action, it makes it a bit clearer what's running. So I get a lot of product updates, which means I do a lot of Shopify product model.update actions, but also Shopify product variant media, Shopify product media, Shopify product auction, Shopify product variant update, like all those kind of inner models from the chunked up webhook payload that might need to be processed into your application will be shown here. And this is helpful for understanding just by volume what's costing a lot and help you understand like, oh, if I disable this model or I update this less frequently, I might find, these numbers go down. And then again, you can see it by model, by which Shopify shop, so on and so forth. Below here, we can also see actions triggered by either the Shopify sync feature of Gadget or the Shopify missed webhook reconciliation feature of Gadget. So over here, this demo app happens to have some models that need to be synced. They might be sync-only models that don't offer webhooks, or they might be models where either on purpose or through a runtime bug or something like that, we didn't have up-to-date data and the sync discovered that and ran the action to update the data on the Gadget side. So in the past 24 hours, 1.19 million sync actions were run. Clearly, this is when the sync ran right here. And we can see, it was mostly product and product variants that were synced. And it looks like it was mostly this shop as opposed to anything else. If I zoom back out to the 24-hour time range here, I can also see the webhook reconciliation. And so what this is the automatic process that Gadget does every day on every app's behalf to check to make sure there's no data that's out of sync between Gadget and Shopify. So we go and we get all the products whose updated at is newer than the last time, and we make sure that that is reflected in the Gadget database. And if it's not, we run a reconciliation action to do that. So in our case, we did, Shopify product variant media, Shopify product media, product reconciliations were all run here. And again, it makes sense. I think this shop is maybe either webhook filtered or was just a recent install such that these things are populating all the kind of historical data. And then, forgive me this is broken on my demo store, but in your real Shopify app, this will show you the count of installs that are active for your Shopify app. So the number of stores that are in good standing where your API token's working and you're able to make kind of connectivity to Shopify and run requests. I think that's the Shopify dashboard. Okay, so that was an overview of the Gadget operations dashboard. This feature is live for everybody in the product today. If you have any questions or comments about the operations dashboard, we'd love to hear from you. The best way to get in touch with us is on Discord. And we love your feedback too. If there's charts that you want to see or functionality that you think the ops dashboard should have but is missing, please let us know. We're excited about this. We hope you are too. And thanks for watching.